Canadian bacon either. The kids like pepperoni and olives. They want pepperoni and olives on their pizza. Logan says he likes that. Just pepperoni, just straight up pepperoni. Okay. Have you ever bought like the real deli pepperoni? Like forget about the pepperoni you buy this packaged up, like the real deli pepperoni. That just yeah. So I would go real deli pepperoni, real deli Canadian bacon, and then some Italian sausage fried up. That would be. I could throw some bacon on there too. I mean, bacon's good on anything. You can throw it on your finger and you'd eat it. All right, here we go. Find dimensions that give you the largest area of a rectangle whose base is on the x-axis, whose corners are on the parabola y equals 12 minus 3x squared. Oh my goodness, where do we even start? And that's the problem. You see word problems, and you think, where do I even begin? And we begin right here. You draw 4 boxes, and you start by drawing the picture. What does 12 minus 3x squared look like? Parabola? Right side up, upside down. Shifted up 12 units, right? So there we have it. We're going to put a rectangle on the inside. I'm going to call that corner XY. Let's try to give you a helpful hint. What is the formula that's driving this problem? What are we trying to maximize? Area. So I got to write a formula for area. Area of a rectangle. Length times width, or base times height, either one. I'm going to write as base times height this time. The question is, what is the length of the base? Very good. Who said that? Ashworth. Base is 2x. I would go x units in this direction. I would go x units in the other direction. That's a total distance of 2x. You see it? X in one direction, x in the other direction, total distance of 2x, x plus x. Good. What's the height? Very good. The height is y. So I have area is equal to 2xy. Well, it doesn't really help me out. I started with 2 variables. I still have 2 variables. I need to get to 1 variable. It would be nice if we could get rid of the y. Like if there was like something on the paper that told us what y was equal to. Yeah, very good. Doyle's got it. He's whispering. It's 12 minus 3x squared. It says y is equal to 12 minus 3x squared. Or in other words, instead of having x and y, you could have x and 12 minus 3x squared. That tells you the height all the time. Tells you what y is. So therefore, we take that y equals 12 minus 3x squared, and we take that and we dump it right in there for y. So now we've got an equation. Area in terms of x is 2x times 12 minus 3x squared. Distribute that 2x, and I get 24x minus 6x cubed. Do you know what shape that is? Does it make a parabola? It makes a squiggle. Okay, all right. Makes a squiggle. We're going to call it a squiggle, I guess. And that's fine. We're not going to judge. But we do know that we don't have the opportunity to do negative b divided by 2a because it's not a parabola, so we got to look at our calculator. So I type it in, and I zoom standard. I kind of see it, right? I mean, we definitely see the x values, but we don't see the y values, do we? So I'm going to, instead of zooming out, I'm just going to change my window. Maybe I could go up to 20 or 30 or 40 or 50. What do you want to go up to? You want to go up to 100? All right, wow, aggressive. Dane wants to go 100. We're going to do it. It's like his bench press. All right, here we go. So Willie thought it was funny. So, all right, here we go. So it looks like this. There's our shape. Does that have a maximum? Yeah, it does. The maximum occurs at x, a of x. So you tell me, how do I find that maximum? Second, calculate. Maximum, number 4. Left bound, I'm to the left. Right bound, move to the right. (1.15, 18.48). Here's the question. What the heck does that mean? What are we trying to find? Dimensions. This tells me what x is. This tells me the area. The largest area is 18.48. This tells me something that will help me with the dimensions. Plug it back in. If x is 1.15, then what's the base? 2.3, double that, right? I mean, it says the base is twice x, so 2.3 is the base. How would I figure out the height? That says y is equal to 12 minus 3x squared. If we just simply take the 1.15 and plug it in, we should be able to get something. 12 minus 3 times 1.15 squared. And I get 8.03. There you got it. Not too bad, huh? How are we doing today, Duckman? We good? What's your team ranked? Unranked? They are? So are the Gophers. It's okay. All right. I would have lost again this weekend. 2 problems. Hockey team plays in an arena with seating capacity of 15,000 spectators. Ticket price set at $14. $14 a ticket. Sign up. Average attendance at the recent games has been 9,500 people. Market survey indicates that for each dollar the ticket price is lowered, so we're going to drop it by $1 each time. Then the attendance is going to go up. They figure if the tickets are cheaper, people will be like, yeah, I'll pay $13 or 12 or 11 or 10. If you do that, it increases by 1,000. Find the price that maximizes the revenue from the ticket sales. That sounds like an important problem, right? Kind of hard to draw a picture, isn't it? I agree. Now, how do you draw a picture of that? Well, this is where my very good friend, we're going to model this problem by 14 times 9,500, but what we want to do is we want to change that. What are we going to do to the 14? We're going to take 14 minus 1. What are we going to do to the 9,500? Add 1,000. Josie's on a roll. She says, I can be as smart as Dane. Okay, well, that was fun. Let's do it again. What if it's not $1? What if we do $2? Be 14 minus 2 times 9,500 plus 2,000. Do you see a pattern developing? 14 minus 3 would be 9,500 plus 3,000. Do you see how we didn't draw a picture, but we are modeling the problem, are we not? I mean, this is what's happening. We're just wondering, should we lower it by $1, $2, $3, $4? How much should we lower it? Well, it would be nice if we had an equation. I put it to you that we could use this to come up with an equation, that we could have a variable. What do you think? Revenue is what? 14 minus X times very good. 14 minus X times 9,500 plus 1,000X, where this is the ticket price and this is the attendance. That looks like a good equation. Now, that wasn't very hard to come up with once we saw this, right? But if we went to lay this out, I mean, that would have been pretty hard to think through on your own. So when you don't know what to do, just start doing something. Sometimes it'll lead you to the right answer. Let's come up with an equation. R of X is, I'm going to multiply that bad boy out. 14 times 9,500. Now, I'm fortunate I just taught this class last hour. I remember it's 133,000. So I did not do that on my own. I'm not as intelligent as I look. But I did the next part on my own. 14 times 1,000x was 14,000x. And negative x times 9,500 was negative 9,500x. If I add those together, I got 4,500x. And I did the next part on my own. I took negative x times 1,000x, and I got negative 1,000x squared. And this is where I got stuck, because I was like, what does that even look like? You know what I mean? Like, we don't know what that looks like, do we? Oh, we do? What does it look like? Right side up or upside down? Yeah, we know exactly what that looks like. It's got a negative x squared on it. Upside down parabola. Does it have a maximum? Yeah. Heck yeah. Yeah, it's got a maximum. Maximum is going to happen at x and r of x. Do we need to go to our calculator? How can we find the maximum of parabola? How do we find the vertex? Negative b divided by 2a. Piece of cake, upside down. So it'll be negative 4,500 divided by negative 2,000. This I did in my brain on my own as well. I got 2.25. And then I got confused. What the heck does 2.25 even mean? What does it even mean? It's the x value of the vertex. What does it mean in connection with hockey? Or the revenue that the arena is trying to produce? Okay, so it's the x right here. So what does that mean about my ticket price? I lower it by $2.25. So the new ticket price is $11.75. And that will maximize our revenue. Now, can I ask you just to look a little bit deeper at this problem? There's something else that's kind of interesting here. This is in factored form, isn't it? And we could find the zeros. What number would you plug in here to make 0? 14? So what would be your new ticket price if you lowered it by 14? 0. Does it make sense that you would have $0 if you didn't charge any money? Yeah. I mean, everybody comes in for free, and we don't charge anything, right? We got it. Okay. So what would you plug in to make 0 here? Subtract the 9,500. Yeah, negative 9.5. So let's think about that. If x was negative 9.5, what would the ticket price be then? 14 minus negative 9.5 is 23.5. So one situation gives us $0 for ticket price, and one gives us $23.50. But that produces 0 over here. That means nobody would come. So $23.50 is so high of a ticket price that the attendance would be 0. You would have 23.5 over here, and you would have 0 for the attendance. Whereas if you plugged in 0 for the price, and that would give you 9,500 for attendance. So that's kind of where we're at. So this gives you an interesting model. You know that you start charging over $20 and you're going to have people not showing up, right? So it gives you an interesting piece. Last one. Rectangle is inscribed in a semicircle of radius 16 inches. What should the dimensions of the rectangle be in order to maximize the area of the rectangle? Very similar problem to what we just saw. Semicircle, 16. An inscribed rectangle. Does that look familiar? Area is base times height. What do we call the base? Two x. What do we call the height? So therefore, the area is 2x times y. What's y? Oh, they didn't give us a formula this time, did they? Shoot. We have to come up with one on our own, don't we? How could we do that? We don't even know the equation for a circle, do we? Wait a minute, we do. It was just on our little formative assessment, right? Did you guys not just do a problem about the equation for a circle? Right? I mean, you guys just put something in the form of a circle of x minus h quantity squared plus y minus k quantity squared is r squared. But the nice thing is, what's the center of this circle? 0, 0, right? So x minus 0 squared is just x squared. Y minus 0 squared is y squared. What's the radius? 16 squared is 256. We just came up with the equation for the circle. There it is, in all its glory. There's another way to do the problem. You could draw a triangle where this is x and this is y. Anybody know the length of the hypotenuse of this triangle? 16. If you use the Pythagorean theorem, you get x squared plus y squared is 256. Isn't that exactly what I have? Because the equation for a circle and the Pythagorean theorem are the same stinking things, right? We've been over this, which is the same as the distance formula, which is everything that trigonometry is based around. So you can see either way you come up with that. So all I need to do is just solve for y in that equation. Y squared is 256 minus x squared. Square root both sides. Y is, I square root a variable, so I have to list plus and minus square root of 256 minus x squared. In case you were wondering, the plus square root is the semicircle that sits above the x-axis. The negative square root is the one that sits below the x-axis. So we don't need the negative one. We can just pick the positive one. And so we do have an equation for y. Y is the square root of 256 minus x squared. Again, you can see how important box number 2 is. That's where all the magic happens. Our equation, our area in terms of x is 2x times the square root of 256 minus x squared. Does that make a parabola? I don't think so. It's got a square root on it. Who knows what shape it makes? I better go to my calculator because now I'm in uncharted territory. I will type in 2x times the square root of 256 minus x squared. Whoop. Stop doing dumb things. And I'm going to zoom standard. Guess we got to be smarter than the calculator, huh? Let's look at our problem. What's the biggest x value you could have? 16. So I'm going to change my window to negative 20 and positive 20. Maybe that'll help me out. And then it looks like the y value is the area. So I'm going to have to figure out, maybe the areas are in the tens, maybe they're in the hundreds, maybe they're in thousands. Doyle. Duckman. Give me a number 0 through 16. What do you want x to be? 13? All right. He wants x to be 13. Suppose x was 13. Then we would have 2 times 13 times the square root of 256 minus 1/3 or 169. So I'm going to figure out what that is real quick here so I can come up with a reasonable window. 2 times 13 times the square root of 256 minus 169. And when I do that, I get 242. So in Doyle's situation, if x was 13, he comes with 242. So it looks like our area is in the hundreds. So therefore, I'm going to set my window somewhere up in the hundreds. Let's go negative 500 and positive 500. We'll go big, just like Dane Brownlow did. There it is. That's kind of a cool shape, isn't it? What does it look like? I wonder if we included the negative portion, we would actually, that's the infinity symbol, isn't it? Yeah. Isn't that cool? It's like a bow tie. But we don't want the bottom one. We just want the top one. We know what it looks like. It looks like that. And we want to be able to find the maximum, which happens at x and a of x. Well, negative b over 2a doesn't work, so what should I do? Second, calculate. Number 4, maximum. Up to the left. Enter. Move to the right. Hurry up, little dot. Run. Get to the top. And it falls down. Enter on guess. And I get 11.31 and 256. Hey, that's interesting. Turns out that the maximum area is actually 256. which we saw the 256 come up in the problem. That's kind of cool. But what about this? Do we want to know the area or do we want to know the dimensions? So if x is 11.31, what's the length of the base? Double that. 22.62 inches by, how do we come up with the height? Plug my 11.31 right back in here. That tells me the height. Square root of 256 minus 11.31 squared. Get the same thing. Interesting. It looks like in order to maximize the area, this should be a perfect square, and this should be a perfect square. 11.31 by 11.31, and 11.31 by 11.31. Then we maximize the area. Good work. Take out that homework problem set I gave to you.